Today let's solve the math section in Interviewbit time complexity. This is the first problem. To not waste time, I have already compiled them by taking their screenshots. So let's start the video. And here's the code. Now you have to calculate the number of instructions executed in this code. Now how will you calculate this? So the loop is depending on the variable I. The I is starting from the n, and the loop runs until it becomes 0. So it looks a bit complex, but it's not. Let's see. Starting initially I is n, and then I becomes n by 2, and then it becomes n by 2 square, and then it becomes n by 2 cube, and so on until it becomes n by 2 power k. Okay, now this should be, as I greater than 0, it can never become 0. It should be 1, just after 0. N by 2 power k is equal to 1. This is where the loop ends. This is the last condition that holds. Now n by 2 power k is 1, which means 2 power k is equal to n. Apply log on both sides. K is equal to log n to the base 2. Now you got the k, and how many terms are there in the, obviously this is k is equal to 0, k is equal to 1 until k. There are k plus 1 terms, which means these instructions got executed k plus 1 times, right? So k is log n, and total number of instructions executed is log n plus 1. And in order to get the Go notation, what should you do? Remove the constants, and it is big O of log n. Let's move on to the next question. Now see this. Number of instructions is equal to, this is the single instruction, and it is there in the loop, which in turn is present in another loop. Now let's analyze it. Initially I is n, so this loop will execute for n times, and then I becomes n by 2, right? I is equal to n by 2. Sorry, I got a bit confused there. Initially I is n, so this loop executes for n times. Then I becomes n by 2, so the inner loop executes for n by 2 times, and n by 2 square times, and so on until n by 2 power k times. And the last valid I is 1. So n by 2 power k is equal to 1, which gives us, as you already know, k is equal to log n, right? And the number of terms in this expression will be k plus 1. So how will you calculate this? What is it? This is the geometric progression, where r is 1 by 2, and a is n, r is 1 by 2, number of terms is k plus 1, like k is n, log n plus 1. So the sum of GP formula, a into 1 minus r power n by 1 minus r is equal to n into 1 minus r is 1 by 2, 1 by 2 power n is k plus 1. This is log n. Wait a minute. Sorry for that. Just a second. A is n is k plus 1 is equal to log n plus 1. So this equation becomes A is n into 1 minus r is 1 by 2 whole power log n plus 1 by 1 minus 1 by 2 is 1 by 2. This 2 goes here. It becomes n into 1 minus 1 by 2 into 1 by 2 power log n. I hope I'm correct. This 2 power log n is nothing but n. So the resultant equation will be n into 1 minus 1 by 2n, which is n into 2n minus 1 by 2n. N goes off, which gives us n minus 1 by 2. This is constant. Remove this. So the final answer is big O of n. Let's check it once. Yes, we got it correct. Next, we'll move on to the next problem. Yeah, now look at this problem. Here, this is the instruction which is in the loop. How many times does this loop execute? Initially, I was n by 2. I is incrementing each time by 1. I is going from n by 2 to n. And this loop, how is it going on? Is it dependent on I? No, it's not. So you directly calculate for this loop first. How many times does this loop execute? And after you calculate this, you multiply with the outer loop so that you get the resultant answer. Now let's calculate this. This function is for only this loop. So j is initially 2 and it's going on incrementing until j reaches n. J was 2 and then it becomes 2 square, then it becomes 2 cube and so on, 2 power k, and 2 power k becomes finally n. So how many terms are there in this? How many terms are there in this? K terms. When does the condition break? When the last condition that holds is 2 power k is equal to n. J initially was 2, then 2 square. It goes on until 2 power k. At 2 power k, it is equal to n, and after that it will break. So the final condition that holds is 2 power k is equal to n. Apply log, k is log n. Now you got the k log n. So how many times does this loop execute? It's log n. F of n is log n. And how many times does the outer loop execute? It's going from n by 2 to n. Each time it is incrementing by 1. So how many times the outer loop execute? it's n by 2 times. So n by 2 into log n gives us bingo of n log n. This is the answer. I hope you understood these problems. Thank you very much.